And this is our last and final problem on rectilinear kinematics, example 3. In this problem, the problem involves a landing scenario where a plane touched down to the tarmac with a given initial velocity, and we're gonna measure how far it can go given a certain distance. What would be the velocity after a certain distance if we know the acceleration? So let's see the problem. It says a jet plane touched the tarmac at a speed of 150 meter per second. So knowns are u, initial velocity is 150 meter per second. The plane is accelerating at a acceleration equals to 75 minus 0.5 s, that is displacement in meter, and the unit is meter per second square. So what are done? These are the two knowns. It says, okay, what are the unknowns? Okay, before unknowns we have another known, that is traveled 409.487 meter. So distance traveled s is 409.807 meter. Unknowns, unknown is determine the speed. So speed is p, or I can write sp is what? So we need to find the speed. Now solution. So we saw that the acceleration is again a function of displacement s. In the first problem we had the acceleration as a function of velocity. Now it has a function of s, and this is 5. So we know that it's a changing motion. We cannot use the formula, so we have to use an integral form. And to connect acceleration with displacement, we know that we have derived in previous problem a ds equals to v dv, and we can do integration. We can plug the value of a, that is 75 minus 0.5 s ds equals to v dv. If we do the integration, we got 75s minus okay, the limit is from 0 to 409.807. So why the initial position is 0? Because it starts as soon as plane hit or touch the tarmac. So that's the 0 point origin, and it travels this length, this distance. So this is the final, and the velocity, we have an initial velocity at the touchdown, which is 150, and we want to know what is the final velocity is. So that's we don't know. So if we do the integration, we see 0.5 that remains s square over 2, and limit is from 0 to 409.807. On the right hand side we got v square over 2. The limit is v from 150. Now if we solve, if we take these two out and move on the other side, we got 150s minus 0.5 s square on the right hand side. We got v square minus 150 whole square. So if we take everything on the other side and plug value s equals to 409, then we get equation negative 0.5 s square plus 150 s minus 150 whole square equals to v square. So if we solve this, we can get the value of v. So let me find. So if we plug the value in calculator, 0.5 into s is 409.807 whole square plus 150 multiplied by 409.807 minus 150 whole square okay, so this will be plus, because this one, if it goes on the other side, it will be positive. So what we got is I'm working on the calculator. So the velocity is 0.4 meter per second. So it's almost about to stop. So this is the final answer. So today we have solved 3 problems. In next video, we will study curvilinear motion, which is a particle motion moving along a curved path. So far we have studied particle moving in a straight line, and study the theory of particle motion moving in a curved path, and in the next class we'll solve problems. Thank you so much.